Hey everyone, the goal here is something interesting with Arizona. Simple regression analysis, but it's an interesting model. So let's bring up this data set. If you notice, check this out. Rattlesnake. It's actually in the ABD package. So as you know, packages are part of R. What makes Rstudio so amazing is you have all these different packages, but they don't only give functions like, different regression analyses like robust regression, etc. But what's interesting is they actually give data sets. So if you first install and then get out of the library ABD, you can get it out. So first we're going to view it. Rattlesnake. Now you need that package first, ABD, see? Get rattlesnakes. Boom, you can view it right here. Male size and temperature change for these rattlesnakes. I've seen rattlesnakes out here in Arizona. They're pretty interesting in the wild. So then you have to attach it. Easy peasy, and then RAT, 3-letter rule, and you get the rattlesnake. So the goal here is to practice hypothesis testing and regression analysis. So you'd have a null hypothesis. This would be there is no relationship between temperature and male size. The alternative hypothesis is there is an increase in male size with an increase in temperature. Move that over. And then the other alternative hypothesis, number 2, there is a decrease of male size with an increase in temperature. This is very important to start thinking about because you have to ask yourself, this data set, that, do rattlesnakes, come out more and then eat when the temperature goes up opposed to going down? And that's very, very important because obviously, people have to understand their own behavior, right? So we need to understand the rattlesnake's behavior out here in Arizona in order to understand the rattlesnakes, our behavior. And when we walk in paths, go hiking, etc., the hotter it is, maybe they're more likely to be out there eating larger pieces of food, which could be you. That would be a great horror movie. Just like Piranha, just like Jaws, the rattlesnake eats the people in Arizona. You heard that here first. So we're really going to do it right here. Poison, because they're poisonous. Is that how you spell poison? Well, I hope so. This is the LM function. That's linear model. We have male size and temperature change. They're both numerical. So the independent variable is obviously temperature change to see if that affects male size. So the male goes first, male size, to C, and then T tilde, and then temp change, because temp change is the independent variable that actually becomes second in this. So you get the dependent variable, the result, the independent variable, temperature change, and then I'll just do data equals, what are we going to equal this for? That's the name of the data set, which is cool model here. So then you just hit enter, you do a summary. This is to get you going on the linear model, and then you do poison. Look at that, a party going on with the poison rattlesnake. And then I always hit up here to be able to see it. This is the call, this is the model, LM, right? Residuals, we won't get into that yet, but coefficients, what's important to know, this is the average, it's a practical value, ignore the intercept. This is the practical value saying with every unit change, wow, 29. I don't know how they measure the male size, but that's a very large increase of male size. Decent standard error, not the lowest, but not the highest. High T value, which means that it is moving. It is not just 0, meaning that it is moving in a certain direction when we add the independent variable. So in this case, it is positive, not negative. And you see the p-value here, very significant, 3 stars. That's scientific notation, which is less than 0.00000, like 8 zeros, 0.3 380, oh no, 7, sorry about that. So that's the scientific notation. So it is significantly under 0.05. The residual standard error is pretty low, but look at this multiple R squared we have, 0.8. That's about as high as it gets. I mean, that is an incredible correlation with this data. So you see that clearly, without a doubt, there is an increase in temperature. So rattlesnakes, we conclude, are much more active during times of high temperatures, which then we have to conclude our behavior has to change, because you've got to watch out for high rattlesnakes when the temperature gets really, really hot, because they might eat you. That's right, you and everyone you love. So let's ggplot this really quick. That's ggplot. So you get rattlesnakes. That's the name of the data set. Plus, we're doing points on this. So the aesthetics, that's the X and Y. You see it right up here. You see X equals temperature change, just TMP, should bring that up. Here it is, see rattlesnakes. That's from the data set. And then Y, which is the dependent variable, would be male size. So that's the result, which is increasing significantly. And then we're going to do GM point. That means it'll come up as points. And we can put a color there. What color do you like? I like, how about dark red? Notice color just equals and then dark red, because you have dark red right there. Very beautiful color. Dark, so we can see it. So some people like beige, yellow, etc., but you can't really see it that well. And then we do stat smooth. That will be, here it is, our line going through. Now we want the method to be LM, that's the linear model, the same. And then comma, I always do SE equals false. That means you don't get that ugly gray part in it, if you've seen other videos I do, but that's, so now let's make what color would it be good for the line? So what matches red? Why don't we just do, how about this dark blue? You gotta put it in quotes. All you gotta do is hit one quote and it will be, look at that. So let's see if it works. It comes up, yes, on the side. Look at that. We got outliers here. So I don't think a robust regression would really change it that much, but we can run it. And you've got it right here. So that is your graph for people who are more visually oriented. So this is what you call linear modeling with quantitative variables, right? And then we graph it. Now, this could be anything. This could be a business model. This could be an engineering model. This could be a model for law. This could be anything. But what's interesting, this is a case where you're just learning linear models, and now you know how to run it, and at least you know how to interpret this model. So in a simulation study, let's just say this could be, if you were doing national security, it could be, you know, a certain season where China, Russia, the United States, etc., goes into certain military exercises. I mean, this could be any type of correlation, but it's a very, very good model. And you see it right here. And this is what models are all about. And this is what statistics are all about. So even if you're using artificial intelligence to get answers, you still need to understand this output. And then you could use different models to check to see if this was actually good, which we're not going to do here. This is just a basic linear model. So thanks for listening, everyone, and I hope you enjoyed the model of snakes. Watch out, don't go out in the heat when it's too hot, or a rattlesnake will eat you and everyone you love. Take care, everyone.